How does the equation change for an object whether it's dropped or launched? Let's take a look at an example of each. So for a dropped object, we have h is equal to negative 16t squared plus h sub o, where that represents our initial height. So when we talk about a dropped object or a launched object, we're talking about an object on Earth, and we're assuming air resistance is negligible here in this case, okay? So our negative 16t squared is going to act as like our gravity in this scenario. And then for a launched object, we have h is equal to negative 16t squared plus v sub o t plus h sub o. So h sub o is the same thing, that's our initial height, but now in this case, for our launched object, we have an initial vertical velocity, right? So that's the initial vertical velocity. So that number could be positive, could be negative, or it could be zero, right? If we are launching our object up into the air, that's going to be positive. If we are, think for example, like in volleyball, if the hitter comes up and they spike the ball down, well, they're hitting it down, right? So our velocity there would be negative. And then let's say we're shooting a bow and arrow or something like that, or if we throw a baseball directly parallel to the ground, well, then in that case, our vertical velocity would be zero. So that value could have a positive, negative, or zero value. So let's take a look at a dropped example, and then we'll take a look at a launched example. So in this case, it says an object is dropped from a height of 60 feet. Write a function that gives the height of the object after t seconds, and then how long does it take to hit the ground. So we're going to focus on our equation here, h equals negative 16t squared plus h sub o. And so h sub o is our initial height, so that would be 60. So we'd say h is equal to negative 16t squared plus 60. And this would be our function that gives the height of the object after t seconds. And now our question says, how long does it take to hit the ground? Well, if h represents height of our object, what would the height of the object be when it's on the ground? Hopefully you're saying 0, right? So we could plug in 0 for h. So 0 equals negative 16t squared plus 60. And we're just trying to solve for t, right? Because t is our time. So negative 60 equals negative 16t squared. Divide both sides by negative 16. So we'll do this in our calculator. And we get 3.75 is equal to t squared. And now let's take the square root of both sides. So we'll do the square root of that, 3.75. And this is positive or negative, right? So we're going to say t is equal to, and this is going to be 1.94 seconds, or we have negative square root of 3.75, or that's going to be negative 1.94, right? So in this case, time is not going to be negative, right? So we're going to disregard that negative answer, and we're going to say it's going to take 1.94 seconds for this object to hit the ground. All right, so now let's take a look at our launched object example. It says an object is tossed into the air, so our vertical velocity needs to be positive, from 3 feet above the ground, and has an initial vertical velocity of 20 feet per second. The object is caught when it falls back down at a height of 4 feet. How long is the object in the air? So we can write our equation, h is equal to negative 16t squared plus v sub o t plus h sub o. So negative 16t squared plus, our initial vertical velocity was 20, so 20t, and our initial height was 3. Now it says, how long is the object in the air? Well, it's telling us that when we toss the object up, and then we're going to catch it at a height of 4 feet. So in the previous example, we were going to see when the object hit the ground, so we said h was 0. Well, here we're catching the object 4 feet above the ground, so let's let h be 4. So now we have 4 is equal to negative 16t squared plus 20t plus 3. And now if we want to solve this, let's set this equal to 0. So let's subtract 4. So now we have 0 equals negative 16t squared plus 20t minus 1. And now let's just use the quadratic formula, and let's figure out what our solutions would be. So opposite of b, so negative 20 plus or minus b squared minus 4 times a times c, all divided by 2a. All right, so we get negative 20 plus or minus 20 squared would be 400, and we have 16 times 4, which would be 64, and that's going to be minus. And we're going to divide that by negative 32. So x equals negative 20 plus or minus, and this is going to be square root of 346 divided by negative 32. So now let's just plug this in our calculator. So we're going to plug that in, and This would be 336. Okay, so now let's do negative 20 plus the square root of 336 and divide that by negative 32. And we're going to get x is equal to 0.05 seconds. And now let's do negative 20 minus the square root of 336 divided by negative 32. And that's going to give us 1.2 seconds. Okay, so now in the previous example, we had a positive value for time and a negative value for time. So it's pretty easy to tell, okay, we could disregard the negative value. Well, here we have two positive values. So how are we going to know which one is the correct answer? Well, let's think about drawing a picture. So if we had our ball right here at 3 feet, right? We toss it up in the air, and we're going to catch it as it comes back down at a height of 4 feet. Okay, so that means the ball was at a height of 4 feet twice, on its way up and on its way down, which tells us at this point right here, this would be 0.05 seconds, right? So we can disregard this time because that was the amount of time that it took for the object to reach the height of 4 feet, not on its way back down. So there would be 1.2 seconds. Okay, and those are the two formulas you can use whether you have a dropped object or a launched object on Earth.